In this lesson, we will learn about LED, and later on we will first light up and then blink an LED with an interval of 1 second. At very elementary level of electronics, every LED has two legs. Longer leg of an LED is represented as an anode, that is a positive or plus 5 volt, and the shorter leg of LED will be referred to as a cathode, negative or ground. Let's look at how we can add LED to Arduino project in order to control. We can see in this circuit setup, longer leg of LED will going to connect to pin number 13 of Arduino through 220 ohm resistor. And the shorter leg of LED, that is a cathode, will going to connect to the ground pin of Arduino. You may be thinking, why the heck we use 220 ohm resistor? So let's discuss about the selection of resistor value. The information that we have at this moment is Arduino runs on plus 5 volt. And since we are using red LED, which has a voltage drop of around 1.8 volt and current drop of around 25 milliampere. Apart from this information from the datasheet and the Arduino specifications, we know that Ohm's law, R is equal to V upon I. So resistance is equal to voltage divided by current. So let's calculate resistor value R resistor by putting the values that we have. So resistance R is equal to Arduino input voltage, that is a 5 volt DC, minus voltage drop 1.8 volt of red LED divided by current of 25 milliampere. So if we put this information, it will simplify resistance R is equal to 5 minus 1.8 divided by 0.025 in ampere, which will give us resistance R is equal to 128 ohm. Now you will think this 128 ohm doesn't make a sense when we are using 220 ohm resistor, right? Actually, what happens is when we do practical electronics as an engineer, we often looked at practical easiness rather than theoretical correctness. And 128 ohm resistor or 120 ohm value of a resistance is a theoretical value, wherein 220 ohm is easily available resistor value closest to 128 ohm. And so it's recommended, but you can choose values between 220 ohm to 1 kilo ohm, at least for this circuit. I mean, at least when we want to control in red LED by connecting to Arduino as a microcontroller. This is a reason to use 220 ohm resistor for red LED as a current limiting resistor. I hope now you are clear about the circuit connections and the resistor value and selection and everything. So let's not waste time and go ahead and start writing a code. So let's come back to the screen and write a program in order to control this LED. So you can see on my screen we have only two functions, a setup function and the void function. This is a basic structure of the code we have seen in the earlier video. In the setup function, we usually write the setting of the pin that we are interested in controlling. So in this case, we're going to control pin number 13, and that is why we should write pin mode. Pin mode, basically the function which is used to set up the mode of the pin. So the pin that we are interested is pin number 13, and the mode we want to set up is an output, because LED is an output device. So we should have to write pin mode 13 and output. Then before we're going to blink this LED, let's try to light up this LED. So once the pin setup has done, we should write digital write. Digital write is the function which can allow us to write high and low value on particular pin. So the pin again is pin number 13, that is where the LED is connected, and we should write high in order to turn on this LED. So once the code is written, we have to go to tools, make sure the COM port, then we also have to make sure write board has been selected, and then we should click on upload button, upper left corner. So now as you can see, LED is turned on and it stays on because we have not done anything. So what we're gonna do is let's modify this program and blink this LED after every second. So what I'm gonna do is I will cut this line of code, and what I'm gonna do is I will write the same line of code into the loop function, because in the loop function whatever we'll write, that will going to happen over and over again. So this loop actually loops the code, and whatever we write, that will be running over and over again. So to blink the LED with an 1 second of delay, we have to use a function that is the Arduino standard function called delay, and delay is the function comes from Arduino libraries itself, and it takes the parameters that is in the milliseconds. So if I write here 1000, that means 1000 milliseconds of delay will be given. If I write 100, then it will be 100 milliseconds. So I'm now interested in giving delay of 1 millisecond. So I'm going to give the delay. So what is happening here is I turn on the LED, then I wait for 1 second, and then I will say digital write, and I will check pin number 13, and I will turn off this LED by writing logic low, and then again I will wait for 1 second. Okay, so this will turn off the LED and wait for 1 second. So what is happening here is, in the setup function we set up the pin number 13 into output mode, because LED is an output device and we have to control the LED which is connected to pin number 13. Then we are writing in the loop function that we want to turn on the LED, then we have to wait for 1 second, and then we have to turn off the LED and wait for 1 second, and this is all happening over and over again. So if we upload the sketch, we can see this LED will turn on and off continuously in 1 second of delay. So now as you can see, this LED is turning on and off continuously with 1 second of the delay. This is how you will going to control the LED. And in the next video we're going to add a button switch where we'll learn how to give an input to the Arduino Uno. See you in the next video. Bye bye.